Okay, so today we're going to be going over improper integrals. Improper integrals are integrals with singularities or with their domain would go off to infinity. Okay, so let's have a look at our first one. Let's say we were going to do the integral from, let's say, 1 to infinity of 1 divided by x to the p, and we're going to integrate with respect to x, okay? And so we're going to attempt this problem with different values of p to try to see when does an integral like this actually converge to a number, and when does an integral like this actually tend towards infinity, okay? So why don't we start off with p being less than 1, okay? So let's say I wanted to do the integral from 1 to infinity now of 1 divided by the square root of x, and this is going to be an integral with respect to x. Now the first thing that you're going to do on an improper integral, and this is every improper integral, is you're going to put a limit on it. You have got to put a limit on it. So this is going to equal the limit now as b approaches infinity of the integral from 1 to b of 1 divided by the square root of x, and we are going to integrate with respect to x. Okay? And now that you've got that limit on there, that limit needs to maintain throughout the entire problem. And so that's going to equal the limit now as b approaches infinity. Okay, so if we integrate 1 divided by the square root of x, what is that going to become? That's going to become 2 root x evaluated at 1 and at b. All right? And so that's going to equal the limit now as b tends towards infinity. That's going to be 2 now root b minus 2 root 1, and that is going to tend towards infinity. Okay? Let's try it if we have a p which is greater than 1. Okay? Okay. So let's try the integral from 1 to infinity of, let's say, 1 divided by x squared, an integration with respect to x. And so that will equal the limit, now as b tends towards infinity, of the integral from 1 to b of 1 divided by x squared, and we are going to do this integral with respect to x. Scoot that down a little bit. Okay. All right. Okay, now we can evaluate this integral in the normal way. And so this is going to equal the limit as b tends towards infinity. All right, so this would become negative 1 divided by x evaluated at 1 and at b, which would equal the limit as b tends towards infinity of negative 1 divided by b, and then plus, well, 1 divided by 1, which equals 1. Okay, so we sampled a p which is greater than 1, which converges. We did a p which is less than 1, which is divergent. Let's just do p which equals 1, okay? So if we did the integral from 1 to infinity of just 1 divided by x, an integral with respect to x, this is going to equal the limit, now as b tends towards infinity, of the integral from 1 to b of 1 divided by x with respect to x, and that will equal the limit as b tends towards infinity of the natural log of x evaluated at 1 and at b, okay? And so that's going to equal the limit as b tends towards infinity of the natural log of b minus the natural log of 1, okay? And that is going to tend towards infinity. Okay. So the general rule for this is that the integral from 1 to infinity of 1 divided by x to the p in integration with respect to x is going to be convergent if p is greater than 1 and divergent if p is less than or equal to 1. Okay? So in general, and this, right, and when p equals 1, this has a very special relationship that we're going to keep. Here, I gotta move this up because it's not getting picked up by the camera. Okay. So convergent if p is greater than 1, and divergent if p is less than or equal to 1. All right? And so when p equals 1, that is really a dividing line between everything that's convergent and everything that is divergent, okay? I mean, involving these types of integrals or p-series. We'll talk a lot about this when we get to p-series and infinite series, okay? So, the integral from 1 to infinity of 1 divided by x to the 1.0001 with respect to x is convergent. And the integral from 1 to infinity of 1 divided by x to the 0.999, this is divergent. Okay? So when p equals 1, that really is a borderline between convergence and divergence.